And David's getting some files ready to go.
I know.
So we can run something, won't have a copyright strike. Meanwhile, CoCo3 is over here, pumping some iron.
Take some note of what's under the CoCo3.
What's under the CoCo3?
I sent you that a while back, but the other guys don't know about
Power switching system for, this is all Tandy gear.
Yeah. And that's new old stock, never been opened. I still haven't opened it.
New old stock, never been opened.
Yeah.
Okay. Well, if we're gonna be dealing with power here, definitely get the weights going.
Back in. Now we should just be able to run, and it should call the 10th file.
I'll just edit a little bit of code there.
Yes, it's working.
Hey, it works. Yeah, it's a lot of noise in that.
It's pretty quiet too, but that might just be the track.
The track isn't particularly loud. Yeah. But it's definitely playing. So that's the original, that's the prototype. DF player.
Are you ready?
Oh, that's a proper volume.
And then I know it's not playing when I power it in.
Yeah. Okay.
Okay, are we ready?
Okay, so what are we testing? What are we listening to now?
This is the LM386 audio amplifier. It's an external amp we've added onto the board beside it.
Okay.
And we're running one of your test tracks.
And we're bypassing, like there is a built-in amp that we're bypassing.
There is, yeah. We're not using that for this test.
Okay. Let's see what we got.
Okay. We're running at top volume, normal equalizer, and our path
You did
to
some-
the file was this.
You did some serious coding here.
I did.
That's really clean. Significantly cleaner than the DF player. Okay, let's hear the other amp options now. That's lovely. Hey David, do you think I could get a copy of this code to go?
Yeah, no problem. Just give me a sec.
Whoa. Some tells me that's running faster than 600 baud.
Let's see that Blue Streak Ultimate on the right side.
Oh yeah, there it is.
That's fun.
Yeah, okay, here we go.
We'll probably get about 2 pages. You can take this with you too.
Yeah.
Are you ready?
Yeah, we're ready. Okay.
Ready for the next amp.
Okay, next amp. So David moves over to the project board here.
And I actually have to pull a cap off the board because I only have one.
Oh, really?
Yeah, so we're gonna move the cap. That's why I started with this one, because this was the little more work to set up. I have to look a bit more where I'm gonna put things. So this is our cassette audio back to the CoCo. And this is our DC bias removal cap right here. Big electrolytic cap. So we'll pop that in there. We're going from positive to negative leg. And this comes on the negative leg of the big cap.
And he's even wearing his Terrace 80 shirt. Perfect.
Just for you guys.
Okay, so this is now going to be running the internal class what?
I'm gonna
AB.
take my pointer here.
Okay.
So this little IC right there, can you see that?
Yes, we got it now.
That's the audio amplifier IC that's on the board.
Yeah.
And we are using this one with this new circuit. The speaker output is right over here on this part of the board.
Yeah.
With this little adjustable resistor across it. I've got it adjusted right now to about 8 ohms. It's really made for a 4 ohm speaker. I could try turning it down even more.
Okay.
So this is just kind of making the amplifier behave as if there's a speaker there like it's expecting.
Which drastically affects the volume it puts out. That's the functional difference, right?
Yeah.
Yeah, okay.
Yeah.
That's
So,
why we care. All right.
And then we've got we're patching into one of the speaker outputs only. That's the green wire. We've got a tiny little ceramic cap just doing a little bit of smoothing. And then we're running it through this big electrolytic cap to remove any DC bias before it goes into the CoCoMp.
Right. So the amp on there comes as a Class D amplifier, right?
It does.
And that uses that thing we discovered, pulse
Width modulation.
Which we were very confused about last time.
We saw weird stuff on the scope. So we could talk about that a little bit.
Well, so is that what we're going to do now? We're going to hear the pulse width.
This is actually not the D amp. I've actually modified a bit, which is a story in itself.
What? How did you modify this amp?
You see this? This used to be all in Chinese. So let me back up just a little bit. With the Class D amplifier, we were getting the pulse width modulation, which made us see a square wave coming out of either one of the speaker outputs. Like you hook up an oscilloscope to one of them, you're going to see it, right?
Right.
But then if we hook the scope up across the two of them, so we're grounding on a one speaker output and getting the signal from the other one, then we weren't seeing that anymore, right? It was looking more like a regular audio wave.
Right, and so even we were expecting the amplitude to go up and down as the volume went up and down, and it didn't move. And we were like, what?
It was really weird.
Because it wasn't about the amplitude, it was about the pulse width, the duty cycle. Right?
Yes.
Right.
It's varying how long the square wave is high, right?
Yeah.
That's telling you how high the amplitude is of the audio signal. So it's sort of encoding it.
Yeah.
And I think what's going on here, and I'm not an expert on it, but I think what was going on is it was not bothering to filter out the square wave on the speaker outputs.
Oh.
Because when you connect a speaker across the two of them, it's got the same square wave artifact still there.
They cancel each other out.
They cancel each other out, exactly. So they're gone. So that's why when you hook a speaker up to it, you're not hearing a square wave through it, you're hearing actual audio.
Yeah.
But when we're only grabbing from one side, we have issues like that,
so
right?
So for our particular application, we just learned a whole lot of theory about pulse width modification, which we didn't really want to know.
Class D amplifiers, didn't want to know about those either.
Okay, so instead of running a Class, like, are we going to hear the Class D now, or are we going to? No, we're not.
Class D is on this board over here, the unmodified board.
Yeah,
that one's still running as Class D.
Because you went ahead and said, well, hey, according to this Chinese stuff here, which I translated, I can cut a trace on this board, and I can make it work like a Class AB, like we expect. How hacky is that?
If you have a look over here at the pinout, there is a mode pin right over there.
Yeah.
I don't know if that comes through in the video.
We got it.
That mode pin, when you pass in 5 volts on it,
yeah,
the chip behaves as a Class D amp.
Yeah.
If it gets 0 volts or if it's floating, meaning there's no connection at all, it'll run as a Class AB amp. So we just scratched away the trace, and now it's running as a Class AB.
Right. So this guy was never designed to run as a Class AB. You just happened to translate some Chinese specs and figure out I can make this work like a Class AB, like we want.
So the board is designed for Class D, but the IC works just fine as Class AB. And when we modify the amp, everything just worked. I wasn't sure it would, but it works totally fine.
Okay.
So that's what we're going to hear.
Okay, we're going to hear it. Awesome.
Yeah.
Okay. Did you put LEDs on the audio lines yet?
I did try that yesterday.
No dice?
No, we got nothing out of it. I think it's because our signal level's too low.
Yeah.
If we get the audio transformer later on, then if we put it on the output side of that, maybe then we're going to get something.
Yeah, we're talking about getting flashy lights as it plays.
Yeah. In time to the wave file, which would be really cool if we get that going. Yeah.
Okay, but anyway, that's just screwing around.
Yeah.
Okay, let's hear this.
Let's try it.
Okay, subjectively, if my memory serves, that is way louder.
I think it is louder, yeah. And it's still clean.
Very clean. Okay, how does it compare to the sound command?
Oh, the sound command's always going to be insanely loud with the TV cranked up, but let's see. Which sound did you use before?
Yeah.
Something like that? So it is definitely, sound is louder than the music.
This is a pretty quiet track, though. So I think it's actually, they're not that far apart.
With the regular tracks, I didn't notice a difference.
There you go. Okay, now I suppose we should hear what the Class D, the evil Class D pulse width modification sounds like.
Yes.
Okay, let's try that one.
Option.
Okay. Right, so we're just for kicks, we want to actually hear what the Class D amplifier sounds like, the one using the aforementioned pulse width modification, which we're not particularly fans of just because it screwed us over. There's nothing really wrong with it. We just are biased now.
We shouldn't call it modification though. Like
No,
this is the modification.
modulation.
Actually.
Yeah, we're the
most,
modification. Yeah.
Yeah.
Yeah. So that means you got to pop that guy off the board and then put this one. This one doesn't have the trace cut that you've done.
That's right.
I'm gonna pop that
It's
guy
still
in.
original.
Okay.
This one, the other thing I did to this one is I had to solder leads on to bring audio signals out into our external amp.
Oh, yeah.
So that's the other reason I had this one on first, so we could listen to that LM386 amp option too.
Yeah, okay. So now we've got the Class D amplifier in. David's got the volume, the pot there. That's a resistor, is it? Or what is that? Variable resistor? Or what is that thing?
A potentiometer, variable
Potential. Okay, so start turning that up. Let's see what we got. Yeah. I don't know if it's coming over this video at all, but there's significant noise whether when it's soft or when it's louder. So we know it's not clipping. The noise is not from clipping. So I think based just on this sort of subjective test here, the Class AB amplifier is definitely the way to go. So our decision is made. We're going with the hacked version of this DY board where we cut a trace, which makes the amplifier go from a Class D, this little guy, go from a Class D to a Class AB. We get the best results. We may be able to get a little more cleaner stuff out of it, but frankly, if we just did it just as is with a few caveats to the sound designers as far as what levels they should use, we'd be good. But David's got some transformers coming through Canada Post, which has been on strike the last month, so he wants to hook them up and see if we get anything better. But in the meantime, looks like we are good to move forward.